Hello everyone. So welcome to the third video in the series matrices. Here is the topic determinant of a matrix. Now determinant is only taken for the matrices having equal number of rows and columns, or determinant is taken only for square matrices. Okay. Now what is this term determinant mean? Determinant actually gives a clear idea or a good information about the numbers displayed in a matrix. Okay, and it is useful in taking many terms, in doing many operations related to this matrix, like taking inverse, taking minor, minor of a matrix, etc. We will come to those topics in upcoming videos. Anyway, determinant is only taken for the square type of matrix, like for example, A, B, C, D. This is a 2 by 2 square matrix, isn't it? And next one, A, B, C, D, E, F, G, H, I. This is a 3 by 3 square matrix. So, we can take determinant for these two types of matrix and even more for a 4 by 4 matrix, etc. Now, what is this determinant is all about? Actually, it gives an idea about the matrix, isn't it? For example, let me start with this 2 by 2 matrix. Okay, 2 by 2 matrix means if I have a 2-dimension system, a 2D system. Okay, now I am going to have the coordinates AC and BD. Okay, A comma C and B comma D. If I am going to spot out this point, like if A comma C is marked and B comma D is marked. Now if I draw a vector means connecting the origin and to that particular point. Okay. Now I get two edges. If I complete this figure, just copy pasting the sides to its opposites, I will get a figure, right? This is now a parallelogram. Now the determinant of this particular matrix means the area of the parallelogram. Okay. This is applicable for the 3 by 3 system again. That is, but at that point of time we need 3 coordinate system. Got it? We need a 3 coordinate system and I need to spot these 3 coordinates ADG, ADG and BEH and CFI. Now if I draw vectors for these points, obviously I get a figure containing these 3 different edges, isn't it? Now if I if I produce a figure from these vectors, I will get a solid. Now the determinant of this 3 by 3 matrix indicates or it represents the volume of that particular figure. Okay. So actually taking determinant of a matrix will be helpful for many such extended applications in this matrix topic. So let us see how all this determinant value is found out. Okay. For 2 by 2 matrix A is equal to 2, 1, 3, 4. Okay. For this example, if I need to get the determinant of matrix A, I have to write like this. A inside modulus symbol equal to, what is that? Take the product of the elements coming in the principal diagonal. What is that? 2 and 4 is the numbers coming in the principal diagonal. So 2 into 4. Okay. Subtraction minus the other numbers product 3 into 1. Got it? This is how you take determinant for a 2 by 2 matrix. 2 into 4, 8 minus 3 is equal to 5 is the value. Okay. Now moving on to a 3 by 3 matrix. Okay. Matrix B is equal to 2, 1, 0, 5, 3, 1. Okay, let me make this 6 and 1 minus 1, 4. Okay. Determinant of this matrix B is equal to, see what you have to do is first you need to focus on the first row mainly. Okay, this is our first row, and we have to pick up each numbers coming in the first row stage by stage. Let us see. For the first row, first element 2, isn't it? I have to have positive 2 here. Okay, so I have to write positive 2, and if I cut the row containing this 2 and the column containing this 2, I will get the remaining a square submatrix, isn't it? This is a square matrix, also this is a submatrix, isn't it? I have to write that 2 by 2 matrix here, 3, 1, negative 1, 4. Okay, this means that I have to take the determinant of this remaining submatrix. Okay. Now, next thing is just rub it. I had positive sign for the first number. Now the next thing is for the second number, I just need to have a negative sign. Okay. Now, okay, just write this negative 1 over here and cancel the row and column containing that particular number, and what is remaining? The remaining numbers are 5, 1, 1 and 4. So, you need to write that submatrix over here, 5, 1, 1, 4. Got it? Now, as I said, you just need to focus on the first row elements. Okay. Now, the last element in the first row is 6, isn't it? For that, just round it up, and this time you are having a positive sign again. See, always you need to have alternate positive, negative, positive. Okay. So, positive 6 is the next number. Cut off the row and column associated with that particular number. Write down the remaining numbers. I mean, the submatrix 5, 3, 1, negative 1. Okay. Now, as you know, to get the value for determinant of 2 by 2 matrix, it is easy to calculate this thing, isn't it? You know, I have just told the way to find out the 2 by 2 determinant of 2 by 2 matrix. Okay, so let's move on. 2 into, what is this? Start from the principal diagonal elements. 3 into 4, 3 into 4 minus 1 into 1, minus 1 into 1. Okay. Now, write down this negative 1, just copy it down, and starting with 5 into 4 minus 1 into 1. Okay. Now, positive 6 into 5 into negative 1 minus 1 into 3. Got it? So, if you need to get the value for determinant of 3 by 3 matrix, definitely you have to have the idea to get the value of 2 by 2 matrix determinant. Fine. Now, so reducing it up, we get 2 into 12 minus 1, 13, isn't it? Minus 1 into 20 minus 1, 20 minus 1, 19, positive 6 into 5 into negative 1, negative 5 minus, this is 1, right, 3. Negative 5 minus 3 is negative 8. Okay. So, 2 into 3, 26 minus 19 minus 48. What is that value? 26 minus 19, you will get it as 7, and 7 minus 48, you will get negative 41 is the determinant value. Okay. Similarly, for the 4 by 4 matrix also, the pattern is just the same. I'll generalize it, A, B, C, D. Okay, what you have to do is focus on the elements in the first row. Okay, these are the elements. Now, for the first number you have to have positive, for this negative, positive, negative. Now, positive A into, write down the remaining submatrix. Here this time the submatrix is of order 3. F, G, H, J, K, L, N, O, P. And the next step is negative B into, when I cut off this row and column, I get EGH, IKL, MOP. Then positive C into, write down the remaining submatrix. What is that? EFH, IJL, MNP. And lastly, you will have minus D into the remaining submatrix EFG, IJK, MNO. So, this is the pattern for every square matrix of any order. Okay. So, that's it. If you like the idea of, if you got something out of this video, please do like the video, subscribe to the channel baseyourbtech. Till we meet in the next class, this is Minu signing off. Thank you and take care.